Hi everyone. For this video we're going to be taking a look at interior and exterior angles of polygons. Now we've talked about these two things before, but it was usually in reference to just triangles. So now we're going to extend that to talking about polygons with more than three sides. So just a quick review. Remember, every polygon will have both interior and exterior angles. So the interior angles are the angles that are, again, well, it makes sense, I guess. They're on the inside of the polygon. So that's an interior angle, and that's an interior angle, and that's an interior angle, and there are three more down here. So in this six-sided polygon, or this hexagon, there would be a total of six interior angles all around there. This hexagon also has exterior angles. Now remember, exterior angles are formed when you take a side of a polygon and you extend it past where the vertex is. So this right here is an exterior angle, and this right here would be an exterior angle, and this right here would be an exterior angle. And there are going to be, if I extend each vertex, if I extend each side in one direction at each vertex, then you'll create the same number of exterior angles as you have interior angles for your polygon. So in this hexagon we can see we have the six interior angles here, and then 1, 2, 3, 4, 5, 6 exterior angles right there. Now, we remember that for a triangle, the interior angles sum, or when you added all the interior angles together, we had 180 degrees. And we also talked about that for a quadrilateral, the interior angle sum was 360 degrees. Well, for this lesson, we're going to be extending that past triangles and quadrilaterals, and we'll be looking at a way to determine what the interior angle sum is for any polygon. And that comes up in Theorem 8.1 right here. So Theorem 8.1 says that the sum of the measures of the interior angles of a convex polygon, this only works for convex polygons. Remember, they are concave and convex polygons. This little formula I'm about to show you only works for convex polygons. But the sum of the measures of the interior angles of a convex polygon with n sides, where n could be any number you want it to be, from 3 up to however high you want it to go. If it has n sides, then the total of the interior angles will be given as n minus 2 times 180. So if we take the number of sides, subtract 2, and then multiply by 180, that tells us what the sum of the interior angles will be. So in example 1 down here, we have a couple of polygons that we have to find the sum of the interior angles for. So the first thing we need to do is do a quick count of how many sides each polygon has. So I'll just label them here. I have 1, 2, 3, 4, 5, 6. So this is another hexagon, just like what we were looking at up here. This is a hexagon with 6 sides. So if I want to know how many degrees all these interior angles add up to, I'm going to take 6 minus 2 and multiply that times 180. 6 minus 2 is 4. So I'm doing 4 times 180, and 4 times 180 should give me 720. So the total, the sum of these angles on the inside of this hexagon will be 720 degrees. Over here we have a polygon with more sides. So we have 1, 2, 3, 4, 5, 6, 7, 8 sides on this polygon. So we have an octagon here. So to find the sum of its interior angles, we will take 8 minus 2 and multiply that times 180. So 8 minus 2 is 6. So we're going to be doing 6 times 180. And 6 times 180 is 1,080 degrees. So that's the sum of the interior angles of an octagon, 1,080 degrees. Well, what if we make this just a little bit tougher? What if we look at a shape here, and this is a pentagon because it has 1, 2, 3, 4, 5 sides, and we're missing one angle. We know 4 of the angles, but we're missing one of them. And we have to figure out, well, what would that angle be? It has a specific measure, and if I know 4 of them, and I know it's a pentagon, I should be able to find that 5th one. The first thing I need to know is, Well, what should they all add up to, right? Well, it would be 5 minus 2 times 180, and 5 minus 2 is 3, and 3 times 180 is 540. So I know that all 5 of these angles should add up to 540. Well, if I can set up a quick little equation here, I know not everybody's going to do it this way, but this is usually the way I show it. I'm going to set up an equation where I'm going to call this x. This missing angle I'm going to call x. So I'm going to say that 81 plus 123 plus the 89 that I know, plus the 118 that I know, plus the x that I don't know, needs to come out to be 540. If I combine these four like terms, that gives me 411. So I know 411 plus x needs to be 540. Now all I need to do is subtract the 411 from both sides, and that will tell me that x equals 129 degrees. So the measure of angle C there is 129 degrees. On example 3, it says find the measure of one interior angle of a regular hexagon. Now we know a hexagon is going to have 6 sides, and we've already figured out how many total degrees the interior angle should add up to. We know that it should be 720 degrees total, but it's not asking for the total. This one was the sum or the total of the interior angles. Down here in example 3, we're finding the measure of one interior angle. But what we know is that we have a regular hexagon. And a regular hexagon, remember, is one where all the sides and all the angles will be the same. Now, if we know there are 6 angles, because it's a hexagon, there are 6 angles that are all the same, and they add up to 720. We know that we could set it up as like 6 times x needs to equal 720 degrees. 6 angles that are all the same need to add up to 720 degrees. And we can see then from that we would just divide both sides by 6, and that would mean that x is 120 degrees. So for a regular hexagon, each angle is 120 degrees. And they're all the same because it's regular. So that's a little bit about interior angle totals for polygons. One other quick thing we want to take a look at is what the measures of the exterior angles will add up to in a polygon. And this is simple. You don't really have to remember any kind of formula for this one, because the great thing about the exterior angles is that the sum of the exterior angles will always be, no matter if we have 3 sides in our polygon or 43 sides in our polygon, the exterior angles of a convex polygon where you have one angle at each vertex, what you'll be looking at then, that was kind of sloppy, let me clean that up a little bit. One angle at each vertex, the total will be 360 degrees, no matter what. 5 sides, 10 sides, 3 sides, the exterior angles, so these exterior angles down here, will always add up to 360. So if I add 1 and 2 and 3 and 4 and 5 in this pentagon, if I add all those angles together, I'll have 360 degrees. If I were to go back up to the top of my note sheet here, to where I had that diagram and I had a hexagon, these 6 angles that are the exterior angles here, they will all add up to 360 degrees. Doesn't matter what your shape is, the angles on the outside, the exterior angles, will always add up to 360. All right, now you should have a few examples to do out of your textbook, so I want you to go ahead and try those, and good luck.